So, hello everyone. This is the meeting of the Lpwan working group at the IETF, and we are here together with Pascal. Okay, let me just scroll this down. Yeah. So as with any IETF meeting, please read the note well before coming. In the note well, we say that in case you have any knowledge of, that this is your participation here, and everything that you say is considered as an IETF contribution. So in case you are aware of any IPR that may apply to things that you may say that you may want to contribute, please do come to the chairs right after the meeting. And if you don't want to do this, to do the disclosure, please abstain for saying all this. And of course, please do read all the other BCPs about anti-harassment and code of conduct and all these parts. As a reminder, everything the meeting will be recorded, and it is actually transmitted live over the internet. Minutes will be taken, and presence will be logged. Please, we'll be running the blue sheets in a couple of minutes. Please sign the blue sheets. And also, you have the link over the Etherpad for the minutes. As I said, well, this is the link for the minute takers. So we have already some of our minute takers that will be taking care of this. Please go there and write there your name. As a Jabber scribe, Francesca will be our Jabber scribe. Thank you very much, Francesca. So who'll be taking minutes just for me to. So Ivo, thank you, Ivo. Dominic will be contributing.
Sorry. Yeah, it's always a good practice to log in the Etherpad for two reasons. One is if you miss something, you can always read what was just said because somebody just took the minute. And if you said something, then you can check that your words and your name were captured correctly. So even if you don't intend to actively participate in the minute, it's still a very good practice to log in the Etherpad.
Yes, thanks, Pascal. Actually, that's really, really important because we, as a working group that attracts people that come from industry that are first-time participants or don't have the IETF experience, don't have this IETF knowledge. So that's really important. Please go to this link and check what has been said. So on our agenda today, we have 2 hours and 30 minutes slot, which is pretty tightly packed. So we'll be following that everyone keeps in their time slot. It is the announced agenda as in the mailing list. So we have the opening with a short report from Dominic on the hackathon, and then we go over the main drafts, the SHIC over IPUDP, SHIC over CoAP. And we continue with a new presentation of how SHIC is applied to OSCORE. And then we go to the technology-specific drafts for LoRaWAN, for Sigfox, NB-IoT, timescale, and then we have some additional work. And we are very happy also to see the SHIC over 802.15.4 that will be presented. So would you like to add any point to the agenda? No, so we continue as it is. And we start with a short status of where we are and what we've been doing for the past couple of months. So we have fulfilled our charter item number 1, and we're very happy to have our RFC, our first RFC as a group out there, which is splendid because it is one of the first, if not the first document that is out there from our official standardization body, like informational, that gets all the different technologies on the same in the same document, so that it gets really used. We see this, and we're very happy about this. On the second charter item, which is enable the compression and fragmentation, well, we are advancing really well, and today this is going to be one of the main topics. Is the ongoing working group last call of the UDP-IP SHIC. At the last IETF, we were talking about rechartering, of course. And one of the points that we saw also with our ADs and with Suresh, it is that we are going to be able to recharter right after we submit the IP-UDP to the IESG. So this doesn't need to happen like at the IETF. We do agree on the main items that will be there. So basically, we'll have 3 charter items that are taken from the charter item number 2. So continue with the ship or co-op, and then go with data model for contract representation and documents for each baseline technology. And we identified also a new potential working item that actually comes from submissions of 2 drafts that were merged, and it's about enabling operation, administration, and maintenance of Lpwan devices. So, which includes also ping, delete, proxy, liveliness, and so forth. So these things will happen. I mean, they have been discussed, and we will continue with that once we get our work, once we get the IP-UDP submitted to the ISG. And these are the milestones that we have for the moment. We cleared out most of what we wanted to achieve, and today, as I said, we're going to be diving into IP-UDP. I would like to go over in just 1 minute to show us a short history of what we have managed to achieve in the past a little bit less than 2 years. The first thing is that there have been successive hackathons for the past 4 IETFs, and they produced a really important open source implementation of SHIC. So that's really something really important also at the scale of the IETF. And also there have been really regular meetings, virtual interims, so around 5 or 6 between each IETF. So in case you have been there, thank you very much. And in case you did not actually participate in any of these virtual interims, please try to follow it. It's over the WebEx, and there is really very good work happening there. And as I said, we have our first RFC, 8376. So congrats to the authors. And with this, we are giving the hand to Dominique for a short presentation to tell us what happened at the last hackathon. Well, 5 minutes is okay.
Okay. Hello, everyone. Good morning. So as Alex said, we had a hackathon in the weekend before this meeting. So the long-term plan on those hackathons is to provide an open source implementation of SHIC that allows newcomers to try it out, and then after that maybe go and implement their own, but at least provide something for people to play with, provide a reference. And also, to me, it's very important to be able to debug the draft. Our understanding of the draft and implementing it is a good way, and we had yet another case this weekend of something that happened during the implementation. So get feedback on the draft. So if you haven't attended the hackathon and you think, hey, I'm not a developer, that's not for me, don't be shy. It's actually good to come and just read the draft and discuss about the algorithm, and we learn a lot. We benefit from that as well. So please do come. And so our goal for this one was to advance the state of the code to reflect the last version of the draft. And we also had a second goal, which was to merge several pieces, but we haven't achieved that this time. So what got done, apart from having the soccer game being displayed on a huge screen in the back of the room, which kind of distracted the focus. So we had 2 newcomers come. And actually one, maybe sitting in this room, maybe not, just came and said, hey, this looks cool. Your little device is on the desk. What are you doing? And so he had no idea what SHIC was, what Lpwan was. He was from a totally different environment. And he said, yeah, that looks cool. Can I sit and play with you? And we said, yes. I must say, to start with, I said, I'm going to spend quite a lot of time educating this guy, but but in fact, he was very good, and he learned very quickly, provided feedback, and then he started coding and provided very good expertise. So that was a well spent, half hour or hour. Okay, then we updated the seasoned contributors. We always have the same half dozen contributors on the recent draft advances, because not everybody has followed the very last updates. And overall, we got a dozen notes for draft improvement, mostly editorial. This is not well explained, and one functional, which I'm going to talk about later in the other presentation. So we updated our code, the fragmentation code. We still have 2 repositories. We'll do better next time. And we also improved the network side implementation of the compression, Python version, and the repos are shown here. Lessons learned, we knew already from last time that it takes a lot of time to get started with the embedded devices, the LoRa gateway. We try to have a live network running. And so several suggested that we set up MicroPython environment on computers so that people who don't have the devices, there was one guy sitting in Japan working with us. Obviously, he was not in range within our gateway. And so that could be a good starting point to bridge the gap between Python 3 on a computer, full-fledged Python, and the PyCom, the devices. So in between, there's this MicroPython for Linux that pretty much anybody can set on his or her computer. So that's something we've got to think about for next time. Make sure we have this range of free solutions and we manage our code based on those free platforms. So this is a list of participants, 2 first-timers at IETF, any hackathon. This guy, Kylie, first time at the hackathon for Lpwan, and Soichi, remote from Japan. So thanks a lot to all. And of course, a few others among you popped in and talked a little bit. You may not be listed here, but your contributions are welcome too. And I think that's it.
Thank you. So yes, for the next presentation. Yeah. So is it you're going to present together with Anna?
Together with Anna.
Okay. So we're switching the slides. And so here for everyone, you can go to data tracker and then you have all the slides that we're using. So everything we're getting live. So you have access to the slides in the same time. So thank you.
So hello everyone again. We're going to talk about this draft IPv6 UDP over SHIC, and as you may know, it has 2 parts. One is the SHIC generic compression mechanism, and the second part, which is by far the smallest, is the application of SHIC to UDP and IPv6. Okay, that's the agenda for today. So we kind of split the time in sections so we can keep track of time. So Anna is going to talk about what has happened since IETF 101, the interim meetings and the versions we've published. What's coming up next? Ticket status. There was the last time Suresh mentioned that he wasn't able to track, where all these tickets had been resolved, in which version, etc. So we've gone through that exercise, and then I'm going to come back and talk about the single padding algorithm, which is a major, the single technical change we made since 101. And then we'd go through the comments received since we started this second working group last call.
Thank you.
Sure.
Hello. Again, it will be a little bit different from last time. There will not be a talk show. He don't want to do it. But this time I will present a part of what we have done in this period. So there has been 5 interim meetings since the last IETF, where we published from version 10 to version 16. So we have made a lot of changes in the document. So the first version 10 includes almost the 10 first tickets we have discussed, from decouplet, fragmentation and compression, the role ID, all the terminology from chic packet, chic fragment, and so forth that we don't have before. Then we start working in complete this terminology and improve the figure 3 that shows where fragmentation and compression is done. We take ticket 15, that is a list of things that we need to define in the technology documents for the Appendix T. We answer more questions or comments we receive in the tickets about the DTAG, and we delete the R size in all the figures of the fragment part to be more clear. In version 12, to be consistent with compression decompression, we add fragmentation and reassembly in order to have both sides in both part of the chic document. We have a very big discussion about the how to compress the variable length fields, and we decide to eliminate the white argument in the LSB in order to be more easy. In version 13, we completely add all tickets 18 about the variable length field text. Then in the last 3 versions, we continue working in the tickets we have. Then we discuss about the boundary that was not very clear what this means, and we change it for L2 words. We decide to pad once, then this is a presentation that Dominic will make just after. Instead of padding twice, we are only using a single padding. We decide to put a role ID, the same role ID in the ACK from the role ID we use in the fragments. We change the UDP checksum, thanks to Pascal for this input, in order to get a best MIC and UDP checksum compression. We fix some inputs we get from the mailing list of the state machine of ACK always, and we'll leave, even if Dominique was not agree, the C bit without explanation. So he put a bomb. In the last interim meeting, we run the second last call for this draft that we hope we can close today, but we will see. We think we received the comments from Pascal, and we presented in the last interim, and we have received most comments from the mailing list that we will present today after these slides.
Hello?
Yes.
If I may say, I see that Charlie is not here.
No.
We have Juan Carlos here. I understand from private conversation with both of them that they did not fully complete their review in time, and that can be very understandable because the IETF loads you a lot the weeks before the IETF, pretty much. So my wild guess is, based on discussion, we'll probably extend the workgroup last call like a week to give people like Juan Carlos and Charlie time to fully give us all the details they want. Charlie was clear on that. Juan Carlos, I was not 200% sure, but I think you still have things to tell us, right?
Oh, thank you, because I can take my vacations. Great.
No.
Oh. Okay, what's coming up next? So we will not close the second last call, as you have here just now. We have to process the comments we receive from Pascal, Lars, Soichi, Charlie, Juan Carlos that we will present. And we hope we can publish version 17 as soon as possible after my vacations. And we can publish the draft to the ISG. This is Anna. Okay, ticket status. You can follow the tickets in the track. They are all closed. I put all the.
All that pertain to this draft.
You have also put there. Okay.
No, I mean they are all closed. All those who pertain to this draft are closed. But if you go to all tickets, the first link, that's all the tickets for the working group.
Yeah.
Okay.
Yeah. In the track there are all the and there are only one for co-op draft, and the others are for IP. So here are the tickets number. But what I want to say is that in each ticket, before I close it, I put the section in the draft that talks about this, how we solve this ticket. So if we have some time, we can comment. I think you have some slides about the tickets at the end of the presentation.
Yeah, if you're interested in following the tickets, what happened, which version were they implemented at the back of the presentation, I don't think we're going to have time to go through that. We have a full table with the 29 tickets, version blah, first appeared, section blah, blah, blah. And so if you're worried that we may have, missed a ticket, then you can track where it went and see if the outcome is appropriate. And
Fabulous.
So we may have new tickets to be opened today as following the comments. Okay. We're on time. Single padding. So again, this is the only technical change since the last IETF meeting. So I wanted to explain to you what happened. This was extensively discussed at the interim meeting, but I understand that everybody is on the interim meetings. So the idea was floated actually by Laurent, I remember, at one of the interim meetings. He said, hey, you know what, I think we could make it work with single padding. And so this got me excited and say, oh, I'm going to look into that. And we had a little meeting between us. And then I presented the proposal, said, yeah, I think it works, proposed that the next interim meeting, then a mail went out to the mailing list asking for opinions, and we got 6 positive responses, no objection. So at the next interim meeting again, we decided to integrate that proposal, so we made a change to SHIC, mostly fragmentation, as a result of that. So I understand it was not needed, but I think it's better, and I'm going to show you why it's better. So it first appeared in Dash 14 in end of June. So what is it about? Oops. Yeah. Before that, so until version Dash 14, this is how it worked. How do I get the pointer? Yep. Okay. Before that, so sorry to recap. We have compression on the top, fragmentation at the bottom. These are two kind of sub layers within SHIC. And before that, what we had is we do SHIC compression, so header compression, which turns a IPv6 packet typically into a bunch of bits, which are the compression residue and the rule ID, and then either we send it. If we don't need fragmentation, or if the layer 2 does fragmentation for us, we send it to the receiver that does decompression, or we go into fragmentation and send the fragments with an ACK mechanism. So because this is just a bunch of bits, SHIC is totally bit-oriented, not byte-oriented, then before we send it, we maybe most often on most layer 2s, we have to do some kind of padding to adjust to the next byte. And so until Dash 13, this was done here. The compressed packet that we called a SHIC packet was padded to a byte. before it was turned to fragmentation. And then fragmentation would send fragments, most of them without requiring any padding because they are inherently byte aligned. I'll show you why. And except the last one, which has so many bits to send that it cannot be naturally aligned to a byte. So we would have padding on that last fragment. So this meant we had two paddings, one here, one there. Looking at the same thing another way, this is a SHIC packet, which has its compressed header, the original payload of the IPv6 packet that we don't compress, and then the padding to a byte to make this an integer number of bytes. And then we take this SHIC packet and cut it into fragments. First fragment has a header, a fragment payload, which is part of that. Second fragment, third fragment, etc., etc. Last fragment takes a reminder of this SHIC packet. And because this one is not byte aligned, it would be aligned to a byte with padding to second padding. So this is only in the case we do need padding, I must say. This is entirely optional, but if we do need padding, we would do padding twice. So we would add at most 7 extra bits here for byte-oriented technologies, and at most 7 extra bits. So overall, at most 14 extra bits. So you may wonder, why is this inherently aligned to bytes? Why don't I need padding here? And this has been often raised as a question either at the hackathon or on mailing list. People would usually do padding here because they didn't quite understand the way this works. So fragment header is a bunch of bits. It's a weird number of bits, a weird size, not byte aligned, nothing. So what we mandate in the draft is that as a payload for that fragment, you take from what you have to fragment, you take a number of bits that is also a weird number. It's actually complementarily weird, such that overall it's a multiple of bytes. So conceptually it's easy. Yeah, it involves a little bit of shifting to get that number of bits out. But all the fragments, but the last one, are naturally aligned to bytes by this mechanism. So this is, again, the sending part, and this was until -14, the receiving part. And so here, reassembly gets all the fragments, puts them back into a reassembly buffer. Yeah. And then what happens to the extra bits, P2? Well, because it was known that the SHIC packet originally was byte-oriented, then those extra bits could be removed just because they dangle off the end of the last byte. And so that's a byte trimming stuff. And then things go up into decompression, and extra here, the SHIC decompressor works out from left to right. Rule ID picks up the bits that it needs in the compressed header and rebuilds the packet, and then extra bits are dropped. So naturally, the padding disappears here. So what we've proposed is save this 7 bits, so go from up to 14 bits to up to 7 bits. And actually, you only need padding when you send things over the layer 2. So we don't need padding here, but only on the horizontal lines. So what we've said is we get this SHIC packet, which is a bunch of bits. And if we transmit it here, we pad it. If not, we just give it to fragmentation. And again, here the fragments go over the L2, and the last one is padded as needed. So about the same diagram, except this time the last fragments end here. We only pad if we send without fragmentation. If we fragment, we pad the last fragment, but we don't fragment pad 1 actually into the last fragment. So now the question, which is a bit tricky to understand, is how do this padding get removed? And so what we're saying is that at decompression, anything that's left in the buffer once the packet has been decompressed is dropped anyway. We don't care whether it's pad 1 or pad 2. It works the same way. If it's extra, it gets dropped naturally when you decompress the packet. So these bits that we introduced here will be removed there. So that may be a philosophical question in terms of layering APIs. We get these questions. So if you want to reopen that question, we can talk about it, but actually it works. So again, we decided we would implement that. And so it's in the text and it's being implemented at the hackathon. Okay, I think yeah, I'm ahead of schedule. Any question on that? So yeah, again, if you plan on implementing Shake, make sure you understand that we got a comment from the LoRa guys who got it wrong on first reading. So reuse the slides to make sure you understand this one, actually, how it works. Okay. Yeah, you do that part? Okay.
Okay, let's talk about ticket 15, Appendix D. Okay, thank you. What is this? Well, until now it is still raw. It's a list of parameters. We have not structured them. So there are no logic how to use it. The one question we have is if it's in the appendix, is it normative content? No. So it's an informational part for the technology-specific documents. What we were thinking with Dominique is perhaps we can structure this list because we received some comments about what happens if I don't use fragmentation. Do I need to specify in my specific technology document the fragmentation parameters even if I don't use them? And I say no. Normally it's a list, so if you don't use it, you don't specify it. So in order to perhaps give more clarity to this list, we can structure it in the use case, in mapping architecture elements, layer 2 integrity checking, role ID numbering on format, the L2 word type, if it's bits, bytes, or something else, and all the fragmentation parameters part. But again, I don't know if this will help or not. It's a question. If you want that we structure this row list, or we leave it as it is. That's it about Appendix D. You have something else to?
Yeah, I think that was a comment we got at least from Charlie, that this list was a bit like a laundry list. I'm not sure everything was needed, especially if we didn't implement fragmentation. So we will restructure the list, make it hierarchical. Does your layer 2 have fragmentation? Yes. Does your layer 2 need to use fragmentation from Shake? Yes, no. If yes, these are the parameters that you need to define. If not, you can just ignore that subsection. So it's an easy one.
It's not normative. You don't have to make too much effort. I mean, the people who will implement those specs, they will be bright enough to see what's needed for them in that list.
So I wasn't sure, because last time we said, again, that was a comment from Suresh, I think, that created ticket 15, was that you have to make sure that you spell out all the parameters that a technology-specific document needs to define. So don't define the parameter, but list that, make a note that these parameters have to be defined by somebody else. So is that normative or is that non-normative? If it is, it can't stay in the appendix, right?
Well, yeah, but the thing is that, right, I mean, if there is a technology-specific document that doesn't specify one parameter is left out, well, it's not possible, right? They need to specify all the parameters so that it works on the technology. So what you put here is basically a guideline, something that helps them to say, well, okay, well, I need to specify that, right? But it doesn't remove from them the responsibility to actually, have some common sense and say, okay, well, I really need to specify all this. So
your spec would work exactly the same if this annex was not there, right? So you don't need to put that from annex to your spec because it doesn't change the way your spec works. If some technology-dependent document does not use a particular term, it can always say not used, listed, not used. Blah. Explain why. Done. So don't spend your energy there. We have to ship this draft.
Okay, so basically you're saying this can stay as an appendix. I wasn't sure about that.
If your work would not work without it, it could have to be up there. But you remove it, it changes nothing to the implementation.
Right. Okay. Good.
It's a helper for the other guys, right? And the launch release is perfectly okay.
Okay.
Okay. Okay. So yeah, since working group last call number 2, we got quite a lot of comments. Some of them late last night, but we had an early warning anyway. So I'm gonna we structure them, and I'm going to go through them. And if the authors are there, I want to explain. You're welcome to jump in. So we got a comment from Lars about the way we compress IPv6 traffic class field. So it's not about the generic shake mechanism. This one's specifically about the section that says how UDP and IPv6 are compressed using shake. And so right now we said traffic class will be ignored and reconstructed from a constant on the other side. And Lars said this is what traffic class is the field where ECN bits are stored. It's overwritten with ECN bits. And so if you use the ignore matching operator, you'll bleach them out. That was his expression. So you'll make the ECN bits disappear. So yeah, in principle, this is a good point. It's right. But the question was then, the kind of devices we're talking about on LP1, do they actually need the ECN bits? Are they sensitive to them? As far as we know, no layer 4 that we use in the LP1 space uses ECN. So I don't think we miss a lot by ignoring the ECN bits. But in any case, if we had to take ECN bits into account, then yeah, we should either transmit the traffic class field info, or we could compress that field because these bits are on the LSB side. So we could transmit only the LSB bits. Does that make sense?
As long as you provide a way for the guy who will need it one day to transport it, so you don't force that the matching operator is ignored, but you also say, hey, you can use this alternate matching operator if it makes sense for you, right? You're okay, because people won't use it, but at least it's possible.
Right. So what do we do? Do we change the draft to say if you want to use this you do this, or we rely on somebody else to do something differently?
Well, the point is right now we are doing IP UDP, so we could get the ECN bit in, but we could not reflect it out because we don't have a transport that carries it, right? And so unless CoAP later carries the ECN at the CoAP layer, it's not transported. We don't have TCP, right? But in the future, if you do TCP, then you will have to make sure that you can, if you wish, transport the ECN bit.
So we have a section that says how we compress IPv6. So
well, since 6LPWAN is like that, right? We have this the TOS bits, and you have various ways of, depending on some settings, you say, oh, I elide it completely, or I put it totally in the clear. Since we won't be using it, we don't have to be too good at compressing it.
Yes, en tout temps. So we have a toolbox to do compression, and it works with the toolbox. Then we have example how to compress IPv6 UDP, and we cannot go on all the cases. So maybe it's just to add things that say, okay, you can send the ECN with LSB in that section, but that's all.
If we do not mandate ignore, we are all set.
You said example. I'm not too sure. That at least 2 parts in that draft. One is a generic shake mechanism. The other one is UDP IPv6 compression with shake. So is this an example of UDP IPv6 compression, or is it a standardization of UDP IPv6 compression? If it's an example, then we don't care.
Yes, we have to avoid.
Make sure the
must.
text doesn't say that it has to be ignored, right? It's just make sure it's spells like that.
Okay, and in your opinion, what is the purpose of this draft? Is it provide an example or provide a standardization of UDP IPv6
No, but
compression?
we have the general mechanism, right? The general mechanism allows for it. So just make sure there is not a word somewhere which says, oh, the only matching operator for ECN is ignore. If we don't say that, then just apply the matching operator you need.
So to you, the section on UDP IPv6 compression with SHIC is purely recommendations. There shouldn't be any must in there.
No, but it can say you can compress it this way or this way or this way.
Okay.
So yeah, I agree with this, and I actually looked at this. So it starts with if the diff field does not vary and is known by both sides, the field descriptor blah blah blah. So it starts with if the diff field does not vary. So for me, that's like a generic framework, and you say, okay, well, it's applied like this. But in case it varies, well, then you can use some of the other things that are in the tool set. But actually, this brings maybe a good question is to provide some sentence. But I think it's already pretty reasonable. It's clear that okay, well, here are some recommendations, some general recommendations that works. In case you are able to use the standard framework and you want to do something that is not here, well, just use it.
So you're saying last comment is already covered by the if in this paragraph, so we don't have to do
I
anything.
don't see that it's not, right? I mean,
Okay, good. I like that. Okay, we had a comment from Edgar regarding data unit and MTU. So yeah, we'll come to you and update the text the best we can. Yeah, so that was the technical outcome, one of the technical outcomes of the hackathon. Soichi was working on the implementation of, especially of the new single padding technical solution that I just described. And so we have this MIC computation. I didn't go through it in detail, but we computed MIC over the SHIC packet that was fragmented. And so as we said, it's a bunch of bits and it's no longer a byte-aligned stuff. And Soichi over Skype from Japan said, hey, so he hadn't fully understood this single padding mechanism. And once I got the explanation to him, he said, yeah, but I can't compute the CRC on that because it's not byte aligned. And I said, yeah, you don't need byte alignment to compute a CRC. CRC is just a linear feedback register. But he said, yeah, but all the libraries that I can use are byte oriented. Do I have to write my own CRC code? So that's a good point, implementation point. So do we just say, find a way of computing your CRC on a bunch of bits and don't bother us with byte alignment, or do we specify that we'll take the bits and fill up the last byte so we can use a standard library, or leave it to the technology specific draft to specify how they want to compute the MIC, because the CRC is left to them as anyway.
so if there is an implementer in the room, I'm not looking at anybody in particular, but you guys could come to the mic and say, was it difficult, not difficult? What do you suggest? I mean, 3 questions for implementers now. You will show up. Oh, okay, Arun. How did you do it, the magic?
Arun Aklio. So I agree with Dominic that including these extra bits to CRC would be helpful, since most of the library which you find, they accept the byte array.
Okay, so
Objections?
So we make the implementer's life easier by specifying that we fill up the last byte.
We've got Nicolas.
Aha.
Hey, can you hear me?
Yes, there is a bit of noise behind you. If you could speak up a little bit,
Yes, I
your
can.
voice is a bit
Is that better?
It works, but
I was gonna say that I'm also for byte-oriented CRC. So just padding with the end of the last byte to enable standard libraries.
Yep, sounds good. Thank you, Nicolas.
if you could do something to your mic, because when you'll be presenting, it's a bit awkward.
Yes,
There
yes,
is a
I'll do.
noise.
I'll do.
So I guess we'll do that. We're not going to call it padding because we are doing single padding. So that would be a second padding for the single padding proposal. So it's just byte fill up. Okay, so we got comments from Pascal as well. So that was part of the Shepherd review. This partially filled all zero window is complex. And actually, not everybody understands it from reading the draft. Most people assume that all windows are full, even though it's not, especially in ACK always mode. It actually makes the description a bit more confusing because we go a long way in not saying that the windows are full. And so try to find the appropriate statements that leave that possibility open. Whereas anyway, 90% of the readers jump into the assumption. So
Dominique, there is also a clear benefit when the receiver can infer that it has received the full window.
Such as this?
Probably. So.
Okay, so what's the situation if you haven't followed that conversation? So right now, we don't mandate that the windows are fully utilized. So let's suppose we have window number 0, which starts sending fragments with FCN decrementing. So now at this point in time, we mandate that the FCN, the counter, decrements from the maximum value that's known, win max FCN, in a sequence decrementing down, and then the last one must be 0 and doesn't have to be contiguous. So the sequence like 4320 is legal at this time. And so the issue is if FCN number 2 gets lost, the way the mechanism is described today is that because of the 0 here, the receiver will send an ACK with a bitmap telling the sender what fragments it has received. The sender will discover from the bitmap that FCN2 didn't get through, and so it will send FCN2 again. And so now the draft says the sender is not obligated to send FCN0 again. And so here we have this situation where the receiver got FCN2, but has no way of knowing if FCN1 is going to follow or not. And so the situation stays there until the timer expires. It's not a very long timer, but it's still some time. And then because this timer expires, the sender will now send an empty all 0, which is kind of an ACK request. We'll get the ACK from the receiver, and from that it knows that FCN2 got through, and it will start sending the next window, W equals 1. So we have this extra time here and extra round trip. So if there are 3 options. Either we say, yeah, it works, even though it's a bit longer with a timer and the explanation is a bit harder. We could leave it like this and educate people as to how this is supposed to work. Or we could mandate that windows be full, i.e. you're not allowed to send 4320, you have to send 43210. Or we could also mandate that when you do a retransmission like this FCN2, you have to send FCN0 again, which serves as an ACK request. So these are the 3 options. And after discussing with the authors and with Pascal, we were in favor of option 2, mandating that the windows be full, in part because it makes the draft simpler to understand, leaves less open to interpretation. So in which case it works like this: FCN2 gets lost, but we have FCN1, FCN0. Bitmap comes back, sender discovers that FCN2 didn't make it, sends FCN2 again. And now because all the values for FCN were correctly received, the receiver knows it's the end, and so it's in the ACK, so we don't have a timeout. So I sent a mail on the mailing list proposing that as an option, as a solution, the remedy to the problem. So far we got 5 supports on the mailing list, no objection. So if anybody objects in the room, that's time to voice your opinion. Otherwise, I think we just go for that.
Juan Carlos Zúñiga. No, I support option 2. And in fact, looking at the detailed text, I think that is fine for the sender, for the receiver. I think we might need to specify that the SHICAC must be sent after either a null 0 or 1 or the last fragment, because at this point we know which one is the last fragment that was retransmitted.
I think the text is already there.
I'm not
You found it
sure it's
missing?
clearly, but well,
Yeah,
it
the
was
text-
late night when I was reading
I
it.
think the text says if the bitmap is full, we'll send an ACK. But if the windows don't have to be full, then the ACK
Right.
may legally not be full, even though all the fragments have gone full.
Right. If that clarifies that
But yeah,
behavior, then that's fine.
To do for Juan Carlos, check that the text is there or not.
well, we'll go through it anyway. Pascal had another comment. The text sometimes talks about the expected window, and I'm going to use that drawing. For example, here we are, oops, why is it? Here we're sending FCN4, FCN3. They have the W bit 0, so at this point we are expecting more fragments from window 0. This is the expected window. And the text says if we get a message with that looks like a fragment with W bit equals to 1, we reject it because this is not the expected window. So in this example, it's easy. What Pascal commented on was that at some point, there is a point where a receiver doesn't know what it expects, and the text looks like we always know what we expect. And for example, again, in this document, in this sequence, after the ACK has been sent out, the receiver could legally receive either the next fragment for the next window, so the window bit has been flipped, or the ACK has been lost, and the receiver, the sender will send an ACK request under the form of a null 0, and this one will have the window bit 0, and both situations are perfectly legal. So in this case, the text should be clear that the receiver is not expecting anything, neither 0 nor 1, or expecting both, actually. And in fact, if we implement the change that the windows be full, then this kind of goes away.
There is another side effect of this expected window, which is if you just silently drop the wrong window, then you'll come back to the right window, but it's actually window +2. And so I'm just wondering if we really don't agree, and that's the text is very clear on that, and there are good reasons for that, to get packets out of order. Seems to be that if you start being in the wrong window, the only thing you can do is abort. But maybe I'm wrong. You should, I mean, silently dropping the wrong window. So like the sender sends window 0, you're on window 0. Then we move to window 1.
Who is we? Is it the sender,
Well,
the receiver?
The sender is always the one who moves to window. The receiver has no way to change window. So you switch to window 1, but for some reason the receiver still thinks it's on window 0. So we are in this mismatch situation. So if we just silently discard, as the say,
We being the receiver.
The receiver. No, thank you. You're right. So if the receiver discards blindly, now when we go back, sender goes back to window 0, it looks like, oh, we just dropped those things, we're back on the window 0 we were. But no, we flipped from 0 to 1, and to senders, we flipped from 0 to 1 and back to 0. Meaning we're completely out of sync. So the only thing that can really be done is to, I think, if we get the wrong window, it's not just to drop the packet, but probably to abort. But that's maybe, no, I'm wrong. Okay.
Anna here, just one comment. What happens if we put the state machine in the text? Because I think the state machine is more clear than the text. And now the state machine is in an appendix that will not be taken out.
I have a slide on that coming up next. But
do that, we necessarily need to redo the work group last call. Basically, we almost agreed that it will be one more week. But basically, if you move text, this is like a key component, right? So if we say, oh, that becomes normative PS, that's a work group last call thing.
Okay, well, we'll discuss about it. But
okay, Laurent, to come back to your comment of aborting, I think it's very dangerous, because if you have a queue where you have a delay and maybe you have a packet that stays in the queue because of a transmission error, you may receive twice the same thing, and so it's better to ignore it than cutting all the connections. So there is some very strange behavior sometimes.
Let's look at the flows very carefully, because I think this rule that we can't receive things out of order, and because the sender is always the one which decides when the window is, if we are very clear on when we do not expect anything, right? And this was the mistake we're fixing here. If we know exactly when we can expect something and we know what that thing is, with the out of order rule, I don't think it's possible.
It's not out of order. It's more a queuing mechanism in the
even if there's a
network
queuing,
server.
things arrive in the order that the sender sent them.
But here you kill everything. So
Yep.
I'm not.
But if you don't, I mean, you will start taking you will send. I mean, if it's a big thing with 5 windows, you will receive part of the first window, drop the second window because you're out of sync, accept the third window as the first one, and then the fourth, and then the fifth, and then you go to the make and you discover you're screwed.
So we can go into details, but there is queue management in the network gateway, and maybe we can have some delay in what you are sending.
Delay doesn't disorder.
Yes, so that's what I said.
So if we can prove me there is a valid disorder somewhere, I'm very scared.
No, there is no disorder. But
okay, so we should, when we expect a certain window, we should always have that window. And if that's true, and we are in a situation where it's not the case, something's broken. And
you know what? We've been banging our heads on that for years now. I can remember a design session, was it in Dallas? We really, I would recommend, my feeling is that we should make this simpler so that we at least agree what works and what doesn't, and we don't need half an hour to just describe a potential issue. So the full windows is one thing. I think another one just dropped from my head. Anyway, icon error, in my opinion, is one dangerous situation where we create this misalignment between the receiver and transmitter very easily. And the last comment that Anna mentioned is another one. Pascal, you had that comment as well, saying the text on fragmentation is still hard to parse. And I added the second line is mine, actually. I agree, there's many ifs, many otherwise, which you don't quite know what if they relate to,
and
many other hands.
Which have nothing to do there.
And also maze. Okay. So this text is hard to read. I totally agree. I would be in favor of using pseudocode so that with, parentheses, braces, so you know what otherwise, what if otherwise relates to, etc. And when I told that to Laurent, he said, yeah, that's the very reason why we drew state machines, because we were banging our heads on the text and couldn't make a sense of it. So we drew the state machine. So this is what is in appendix. And this is a formal description of the algorithm, except right now it's non-normative, it's an appendix, and the text is normative and the text is hard to read. So hence Anna's proposal that she disclosed before my slide, which is why don't we make this normative? And the text being a readout, an illustration of this.
There's no reason why not, just that we have to relaunch the work group last hour.
Do we want a good document or do we want a quick document?
I think it makes the document much better. So if you ask me, yes, I'm all for it.
Then why I discover your slide, sorry, is because here, when you are in wait next window, if it's not expected, you abort.
Well, yeah.
It's more clear.
I
answered your question there.
Yes, exactly. I see it.
So I don't need any sentence to write. It's there.
It's there.
So,
right. But the current text says you drop. So it's not, the text is not consistent with that. This is what should be done.
Carlos Gomez. So yeah, I would advocate for whatever form we find to better express the content we want to deliver. However, I agree that we need to be careful in the sense that people have been reviewing the draft since as long ago as 05, I think. And basically, the reviews have been on the text of fragmentation. So we may need to to make sure if we want to use state machines as normative content, that there are no like hidden surprises. And also something else is whether the state machines by themselves are like contained, let's say, or then we need some text that describes the state machines, which is new text and so on. So I hope we don't have conversion issues here.
This is why I said we have to reopen the workgroup last call. And even if we say it's just for the fragmentation piece, I mean, we are not asking you to review Chic again, but if we include that, we need people to match the text, find the mismatch, and erase the mismatch, fix that.
Yes, and if I can second that, I think that we need to build a good standard and a good technology, and I think that having the state machines makes things more readable and more understandable. So in case we can open, we can have exactly like like reopen the last call, but saying people, okay, we've got people. You have reviewed the other parts of the text. This was the change, and there is the potentiality of some mismatch between what you have read in the text and what is here in the state machine. Even though I actually, I would be supposing, I would imagine that most of the people that actually did already review the text. They actually also reviewed the state machine. So I would imagine that the load on the reviewers will not be that great in that aspect. But we need to produce good quality standards, right? So for me, I would, in case there is also agreement in the room, I would root for having something that's clearer, that's simpler to understand as normative, and have like a description of text that can be, non-normative eventually.
I see that Juan Carlos and Charlie are now both in the room, and yeah, exactly. So you arrived in the nick of time, Charlie. We are talking about reopening the workgroup last call because we are to close it today. And I mentioned that you told me on the personal discussion that you did not complete your review and you wanted more time. And the question to you that it just falls in the nick of time is whether the time you need is on the whole document or more specifically on the fragmentation piece. Because the discussions we are having now are on the fragmentation piece. And I was thinking that we could close the workgroup last call and say, Chic IP UDP is all set. What's still open is the fragmentation. Let's reopen the workgroup last call for the fragmentation piece, including this as part of the normative text. So that's pretty much the proposal that's on the table. But does it work for you? I mean, do you think that you're happy with Chic as opposed to?
This is I'm Charlie Perkins, and thank you for asking. I see that it's high priority. I think that the solution is nearly in hand. I saw the comments from JC that I think deserve to be considered and worked out. And when that's done, I will try to finish the review, probably 3 weeks or so. Would that be okay?
Yeah. The question really was, do we need to reopen the workgroup last call for the whole specification, or is it enough that we just reopen it for the fragmentation piece? Because you did some review already, you published it. The question is, do you think you covered Chic, and that what's left is on the fragment, or do we need to reopen everything?
Well, the fragmentation is by far the most complicated part of the document. So once that's worked out, the rest will proceed pretty naturally. The comments that I've made about the compression, decompression, I think are fairly easily resolved. And then I think that the examples in the appendix should be proofread, but that's a lot of reading, a lot of pages. So the question is, how close of a review do you want? So I will try to make a review for the redesigned fragment algorithm and finish the review, because I had some concerns about what was being mandated when layer 2 already would do fragmentation. So I will finish the comments about that.
That particular point you can discuss with Edgar right next to you, because that's something that he has raised anyway. And I think we have a resolution for that, so I'm not too anxious. So right now on the table, the proposal will be that we reopen the workgroup last call only for the fragmentation piece, For the NX, they come right out of the implementation running on the air, so I'm not too anxious either. I mean, it's more like for the education of the reader, because the bytes are correct. So it's more for somebody who implements to check his implementation, see if he's getting the same result. But I'm not too anxious that the bytes are correct, because I guess they were captured in the air, right? So, but yes, it's always good that you look at them, but I think it's most for the learning of the users. That's why they are not normative. So yes, I would focus on the fragmentation, unless there is a problem with that.
So I agree with your priorities, but I also know that there are people who can read certain formulations of the mandates in different ways, and I'm quite sure that it can be sharpened. And some people, no matter how many times you tell them, they'll point to an example in an appendix to validate their point of view. And yes, this is why we have interrupts also. But I do think that, well,
I mean,
okay,
if we get review comments, we look at them, because if there is something to fix, we'll be happy to fix it, right? Anyway, we won't let an error in the document when it's pointed out. But what we want is that the fragmentation works.
agreed.
Juan Carlos Zuniga, Seahawks again. So I would be okay with opening for the fragmentation part. In fact, the comments I sent last night focused only on the fragmentation. So depending on the discussion of today, that for me that could be like okay. On the state machine side, though, I think that there could be some mismatches, and I wouldn't mind seeing the state machine as one example of the normative text, but having both in the normative side, I would be not so easy about potential mismatches or duplications. For instance, one example that I was suggesting in the text to clearly separate the sender and the receiver behaviors, because right now they were all mingled. So to me that was a very good way to explain how the standard works. But for the state machine, I think it's a little more complicated to understand what it is. I wouldn't mind, again, having it as an example for an implementer on once you understand the specification. Okay, this is a way how you could implement it, and actually I don't mind where it is in the spec, but I would rather have the text being the normative side and this being an example in whichever part of the standard. And one last comment: the comments I sent do not include yet the state machine. There were a lot of ambiguities in the specification that I tried to clear out with my comments last night, but that still not covers the state machine for sure.
Oh yes, because it was not normative, right? So,
but still, it would have to be cleaned. I'm just saying that I did not go through the state machine because I was first making sure that we had an agreement, and then okay, let's clean the state machine.
The point was, I mean, if we move the state machine to normative, we are asking the group to review it. And yes, I mean, it would be reopened. I'm seeing things like wait for next window. We just said, the point is this is very concise. It's very, I mean, it works, but it's hard to understand by itself without text. I mean, there's no way to do code out of this, right? You don't even know what all those acronyms are for. So certainly this needs to be sustained with text.
Yeah, that was my suggestion, that this be normative and the text stays there, but specifically as an help to read the state machine. Otherwise, to make the text crystal clear, we will need to have states, name states. In this condition, the receiver enters this state, and in this state, if it gets this, it goes there. And basically, we're paraphrasing a state machine. So.
Right, but you need to have text which explains every little block here and explains what's happening where you are. Wait for next window, for instance, is not a very good name for something because you don't know what the next. If we are really waiting for next window because of what we just said, right?
Well, no, we do. No. But anyway. So yeah, okay.
Edgar Ramos Erickson. I actually totally support what Carlos and Carlos has also said about the state machine. I mean, for an implementer, it is very nice. I think you see the state machine, you know, okay, where I put the things, and then I just kind of mirror it in my code. But from understanding the standard, it makes it quite hard. Like, at least in my opinion, knowing what flows to follow and knowing where the things might end up and why and so on, it is not intuitive. And I would prefer pseudocode, actually, type of text that the state machines as they are. There is another reason for this, and is that if it becomes mandatory, it means that I have to basically mirror the same thing in a norm in the standard, the other technologies documents. And it becomes quite hard when there are things that are not used, for example, or when there are things that, how can I say, they might have different, let's say they might deviate from what it is here. Then there are also specific cases or special cases that it would be better that they are like explained in a way more why is like that. So why you send an abort? I mean, what is the reason behind that? I understand that that's what you want to do with the support text, but I would prefer to have it more, if you are leaning towards these kind of things, in a pseudocode, more verbose in a way. Yeah, I would say that's the main thing, is that I'm also worried about how it will mirror then later to the other documents.
Okay. So yes, that's actually a very good point. You're pointing out to supporting an external SDOs that can take text actually from here, make it normative. So maybe one of the points is that we know that we need to improve a little bit, at least the textual description of the fragmentation part, and that has been done already in principle. Maybe what we can do is so give some more time to the reviewers to review this textual representation, and also ask people to review, because I think that the state machine is also an important thing, right? So it is important thing. So we cannot, I mean, even if it's not non-normative, I don't think it's a good idea to have a state machine that does not correspond to the text, right?
Alex?
So yes?
Can I suggest something? It seems to me, from what I hear from the room, that we have a freeway choice. One first choice is keep the text normative, improve it, and the state machine stays as an appendix. And yes, it needs to be consistent. It would be nice if it were consistent. Second choice is create new pseudocode that becomes normative, and pretty much the text disappears, or maybe stays as comment for the pseudocode. Third option is bring the state machine as a normative part and use the text as an explanation for people to be able to read, to parse the state machine. And in the first case, it's pretty much in continuity with what we have, so maybe we don't need to open a new working group last call. We could just extend this one. In second and third case, it's a totally new text and it's a new working group last call. I think that's the situation.
I'm so totally in agreement with you. I mean, that's exactly what I have in mind. So that's why, after careful thinking, I think Edgard is right. And, basically, if we extend the work group last call and thinking about what Juan Carlos told us, we need to ask people, when you review this text, please have this damn thing in front of you and check that what you're reading matches that. So if it does not, then that's an indication that maybe the text has something wrong or something, and then we fix the text. So the text stays the normative piece, but at least the review is really to look at that text in front of that funny state machine. But we don't go through 3 or 4 months of re-editing everything based on that.
Yeah, Juan Carlos again. Yes, in fact, I would agree with what you just said. I would extend it to saying maybe the text is wrong, or maybe the state machine is wrong, because that could also be the case. I would actually go for option 1. To me, that doesn't mean that we don't have to clean the state machine. We still have to look at it. Again, my point was, regardless where it is, it's not because it's in an annex, it will be wrong, because it still will be would create a lot of confusion in the specification. So I'm all for reviewing it, and to me the best way is just to make sure that the text is clean, and then the state machine supports the text. That would be my preferred option. And again, I think that's also time-wise, perhaps the most convenient one.
Carlos Gomez. So yeah, I think my first choice would also be option 1 for the same reasons.
Okay, so since we are not changing anything, there is no confirmation to do on the mailing list, right? We're just proceeding like we are. We'll just extend the workgroup last call, which is something we wanted to, but and we'll word it very carefully that the extension applies only to the fragmentation, and that part of doing that review includes validating that what you're reading fits the final state machine appendix, and that's a to-do for the chairs. Works? Works not? Works?
Okay, well, yeah, my favor was different, but anyway.
Well, voice it.
Yeah, I told it. I'm for moving the state machine in as normative.
So version 3, I guess.
Version 3, yeah. Because it's there already, so it's less editing than inventing the new pseudocode.
Okay.
Because to me, making the text crystal clear is kind of writing pseudocode. We'll have to name the states and in the text currently and say if receiver is in that state and it receives this, then it does that. So basically paraphrasing the state machine. So yeah. But you know.
Anybody else?
But I think, as Ron Carlos said, it's everybody has its own sensitivity to text, drawings, and I know I'm very drawing-based, not much text-based.
Francesca?
From the Jabber, Abdul Salam says, agree making it normative, but if not, take it out totally, the state machine.
Oof.
Yeah, that's his opinion, right?
Okay.
I'd like to do the hum game. So because we don't get many voices here, we get 2, 3, 4. So please, guys, let's hum. So people who want to go for options 1, please.
Sorry, Juan Carlos, I think it would be worth just making sure that everyone understands what is option 1, 2, and 3. I guess you will go for the 3, right?
Okay, so Mr. Option.
Okay, one is improve the current text and the text stays normative. The appendix, the drawing in the appendix is illustrative. And yes, we try to make it consistent.
And the workgroup last call is about asking the people to validate that what they are reading fits that.
Right. So that's option 1. Option 2 is write new pseudocode to describe the algorithm. So totally new text that looks like code. And option 3 is move that drawing from the appendix into the normative section and make it clear that the text that goes with it is just a way to help people read the state machine, but the state machine is a reference.
Okay, so hum.
Am I allowed to use the mic when I hum?
So, okay, yeah. I want to clear something out before actually we do the humming. I get the impression that you believe that if we go with option 1, we will still need to write a pseudocode type of text.
Yeah, because we want this text to be clear, and to me, such a thing which has all this intrication, all these loopbacks, all these states. The only way you make it clear to me as an engineer, with my mindset, is to name those states, because otherwise we end up, the otherwise on the other hand that we have currently in the text. We never know what they refer to. I'm following if, and then the text says else. But what are we talking about? Is it this else or this else or that else?
The text is not very. I mean, I pointed that in my review as well.
Agree.
So it has to. There must be some restructuring, right?
And so either we do indentation, to know what if the else refers to, or we name the states. This is state A, B, C. And when I'm in state C, if I get this, I do that. If I'm in state C and I get this, I do that. And then it's pseudocode. Well, and it's paraphrasing the state machine.
The text is not really structured, but it's mostly like that already. So by just putting things in the right blocks, you would be there. So,
yeah.
I mean.
I'm Charlie Perkins. I just want to strongly agree with what you just said, because we can't tell if the state machine is right or not if we don't understand it. And the understanding comes from the intuition we get from the names on the arcs and the actions and so on.
Yeah.
And also, I would not like to see it be normative, but that's part of the vote.
You would like, or you
I would not like to see it be normative.
not? So you, okay. So, Gert?
Edgar Ramos again. I have exactly similar concern. I think basically, I mean, saying that you cannot put this in if else. I understand that make it very lot of text, I say like that, and then you have to consider what happened when you put an if. So you have to have the else, or you have to have what happened after that if, and so on. But that's what it make it a whole sequence in a way, so that you can think what happened from the beginning to the end. And I think it shouldn't be maybe that mix like it is at the moment. Maybe that everything is analyzed like one case, but maybe there should be some kind of okay, initialization, and then there should be one part of the sequence. Then sending packet, that's another part of the sequence. And then error case, and then maybe there is something that is more specific for the error case. I think the text could be a bit much better structure, so that actually depict the description of the state machine in a much clearer way. So the problem I have now with the two options that you are given, or three options actually you are given, is that it doesn't really reflect what I'm saying, because I don't know, is it number one, meaning that this restructuring can happen?
No.
Or is it that number two? And it's not necessarily that it has to be exactly pseudocode, but when I mean pseudocode is if then whatever else. So then I don't know about these options of voting. Then it's a bit conflicting for me what to vote, because I'm not sure what does include.
Yeah, in my mind, I mean, if you want to be able to track this with the text, and the text should be structured like a section per state or something like that. And then in that state, you explore all the branches that start from there, and there's text for it. That's how I see it. If you don't do that, there's no way to match one with the other.
So from the Jabber, Patrick says, if the text is to be normative, it must be correct and unambiguous. Therefore, the state machine is not necessary nor warranted.
Okay. Juan Carlos?
Yeah, Juan Carlos Zúñiga, just responding quickly to Edgar. A lot of the comments that I sent last night were structuring, actually, the text. It's of course moving left and right, but in fact, I was asking to put carriage returns and separate paragraphs so that it's clearly one action in one paragraph and not in a huge paragraph mixed between sender and receiver. So it goes in line with that thought, and that's why I will personally support option one, because I think the text can be improved widely, and then it's clear to understand what's happening.
And it didn't take you like 2 weeks to rewrite the whole thing, right? It was a pretty straightforward way to restructuring the existing text so that you get this. So
well, it took me a long.
Okay,
but
I mean,
actually, we're having drinks all night, so it's.
Okay.
Okay. So if we need to go with the hum now, option one, the way I hear it, it goes with. We have the text that is restructured in a way that Edgar and that Edgar. Yes, but we have the state machine next to it, and we are able to read it. But the state machine remains in the appendix, so it is non-normative. So that is option one. Option two is we say, well, we have some text, but we need to rewrite some pseudocode around it. And then I'm not sure if we and then we can put the state machine or not. I mean, we'll see. And option three is we put the state machine as normative and we put some illustrative text. So these are the points. So now we can do the humming. So those of you who agree, who would like to see option one, please hum now.
One more for option one.
Okay. Okay.
We should do option two.
So option two.
And match the call. Options.
One more for option two.
Oh, okay. Option three. Okay. Yes. Yeah. Yeah.
Can you do it again, without the guide? Oh, there is some support for
Yeah.
option 3 as well. So we have to take it into the
Yeah. So just for the note takers, so option 1 seemed to be like a bigger, like a majority of the humming that we heard. Option 2, one voice, so I mean no humming, and option 3, there was some support, but we need. I mean,
But the hum was not.
the hum was not.
Sometimes they have. Do you care to show hands in the program? Because I'd like to show hands because the hum was.
Well, let's let's
I mean,
finish this.
you know, some tools are better than others. So please, let's do the show hands because and Francesca, raise as many things as you can, depending. Okay, so let's do the hands. Option 1. Something like 10. Okay. Option 2,
11,
no.
11, I counted.
11. Okay. And option 3. 5, 6, 7. I mean, stop doing this, right? You're kidding me. So it's not, there is no strong. +1.
8.
3.
Well, we cannot say that there is a clear consensus. So
Then there were
yeah.
people who voted for 1 and 3, which makes their life much harder.
Yes.
And
Well,
when those ones are the authors, it makes life even harder. So,
Use the mic.
I'm sorry. I've seen some authors voting for both 1 and 3, which makes life even harder. So there is no clear consensus here.
So we need to take this to the mailing list. That's for sure. I do hear the point of so what Edgar mentioned actually was pretty a good indication for me that if we make the state machine normative, then that could pose some issues with other SDOs actually, getting adopting the technology. But let's get this to the mailing list. In both cases, we will continue the working group last call, and we'll take the decision how we move the things around. I do feel that in any case we need to improve the text a little bit, so that's happening. There's no question about it. And we do need in both options that were priority, we do need to see how the state machine matches to the text. So the work remains generally the same, so people can start working on it, and then we can start a question on the mailing list. So please do answer, and I feel we'll have at least 2 weeks of discussions around this, have a vote on the mailing list, and then we'll take the decision how we see. I think that in both cases we can converge pretty rapidly, and we will see just at what time we end the last call.
Yes, I fully agree with Alex. I mean, most of the work that has to be done is actually exactly the same. Whether we, at the end of the day, we take this finite state machine up or not. Because anyway, the text has to match it. The text has to be understandable and has to be restructured so as to match it, right? The only thing which I'm a bit afraid of, and completely agree with Edgar, if some technology just needs a subset of this or needs a superset of this, then all of a sudden the normative FSM is a problem. And so let's do as if we took option 3 and we'll decide at the last minute, quote unquote, whether we actually effectively make it normative, but let's review it as if we were on the path to make it normative. Because anyway, the text and the FSM have to match. Because anyway, we would have to do, like Alex said, the exact same change in the text has to be done regardless. And
Juan Carlos Zúñiga, just one last comment to keep in mind in supporting Edgar's point. We would have to rethink also the technology-specific documents. So
in terms of reviewing the text and updating the text, we have the same work exactly to do. regardless. So let's work on the text.
Okay.
Okay. Let me fly through the last comments in 2 minutes.
Yes, if you can get down to 1 minute, that would be good.
1 minute. I should have said 5. Okay. Oops. Charlie. Yeah, the MIC, I think we had a discussion over the mailing list about that. To us, MIC is mostly making sure we got all the fragments in, not that each of the message was authenticated. So, well, yeah, just yeah. If I coined the term L to word, which can be a bit, and I said in most generally the SHIC packet is not aligned to L to word. So obviously, if L to word is a bit, then the packet is aligned. Yeah, maybe there's a better wording. UDP elision. Yeah, if you use fragmentation for something. Oh, sorry. If we don't fragment, can we still elide UDP checksum? So yeah, we could rely on L2 CRC if it's strong enough, and the technology-specific document should tell that. Or we could fragment the packet into one fragment just to have the benefit of the MIC if we want to have the MIC.
I don't agree with that.
I'm sorry?
I don't agree with this.
You don't? Okay.
You can always try in a technology-specific document to play that game, but the ISG will kill you.
Because I don't want to rely on IEEE.
When you have a layer 2 CRC, well, a normal IP packet has a layer 2 CRC of like 2 bytes, and then the UDP checksum 2 bytes. So the strength is 4 bytes. Now, if you say, I just use my layer 2 CRC, you just get rid of the UDP checksum, which IPv6 mandates. So you will have to fight the whole world if you just to say, I have a 2 byte CRC, and that's good enough. Okay. So I will not try that on this spec. If somebody wants to try that on this technology spec, well, good luck.
Okay, we'll remove that option. We can still send the UDP checksum in full, not elided, or we could fragment into one fragment so we get the benefit of a MIC.
But there is another discussion which is very different. I want to insist it's very different. It's whether we can elide the UDP. Is it? No. Okay. Let me think that.
Okay. Yeah, fragmentation.
The question was whether we can avoid the MIC for when you have all those fragments, and that's a discussion with Juan Carlos that we can have on the mailing list. But it's not that discussion.
Okay, so making sure people understand that fragmentation reassembly is optional. Yes, this is the intention. We'll try to make it better. And especially in Appendix D, as we said, as Anna said before you came in, it's currently just a laundry list and it's not structured. But yes, the first question should be, shall you use fragmentation or not? And if you don't, then you don't care defining the parameters for fragmentation. Well, we agree that Appendix C is very rough as it is right now. Target value type, I think we'll, I don't know if the chairs want to talk about it now or if we talk about it on the mailing list. Well, they don't know. Implication of out order computation, I think we'll discuss that as well on the mailing list. And Juan Carlos, you have your own slot to discuss this, so I'll just skip them. Is that okay? Is there one more that you don't? This one? Oh, yeah. So you suggested you want more than 1 bit for FCN, even in NOAC mode. Right now, the draft says n is equal to 1 in NOAC. So, well, yeah, that's mostly for alignment purposes, I understand, because when we talked in the corridor, you said you wanted to convey some information to the receivers as to how many fragments will be coming next. But now, especially in the old one, sorry. Yeah, now we don't convey that information at all because we start at maxwin FCN.
Correct.
And it ends up wherever it ends. So there's no information being conveyed. So.
Yeah, so the case, Juan Carlos Zúñiga, would be if we don't indeed start with max win FCN as the start value, we would semantically convey information about the number of fragments, especially in the case that that we transmit in the NOAC mode less than a window. So let's say that less than a full window, let's say. So yeah, not full window, meaning that let's say you have a window of 8 fragments, but you just want to transmit five fragments in NOAC mode. You would be able to convey that there are 5 fragments coming.
You would like
to the receiver. Yeah, I would like to send that information. If we started at not at max wind FCN as the starting.
So
value.
that's 2 changes. One change would be n different, being larger than 1, and the second change would be not starting at max wind FCN.
For
we
the
need
last
to
window.
think.
For the last window.
For the last
only.
window.
Well, it's NOAC mode. There's no window.
Well, yeah.
So we'd need to think about the implications for the other modes, because now so yeah, we need time to discuss it. Okay, thank you. And again, if you want to look at the tickets where they were resolved in which version, it's in the back of the presentation.
Okay, thanks. So we have some homework, but we're in good shape. Laurent, for the presentation, for next presentation, we are running 20 minutes behind the schedule. So we would like to ask some of our presenters to reduce a little bit. So Juan Carlos from 15 to 10 minutes. So if you can shorten it a little bit, the presentation. And Laurent also, because there are 2 parts, there is the co-op part and the OSCORE part. So we had a 45-minute slot. If you can get down to 30 minutes, that would be really great. So mostly spend time on OSCORE to show the usage. Yeah.
Okay, just if I can have my slides, it would be better. Okay, so I'm going to talk about co-op. So in fact, just to give you the story at the beginning, we wanted to have 2 documents, one that describe IP UDP compression, and the other one will be co-op compression. And we move all the good tools in the first document. So in this document, we describe more how to do the compression of co-op. So first, we explain what is the difference between UDP IP and co-op, because you don't manage the compression in the same way. In co-op, you have asymmetry in fields. They are not the same in different way. The fields are variable, so you have different lengths, and all that things make that co-op is a little bit different than what we do with UDP and IPv6. So we have the first section that explains that. And we have also had recently a new section about OSCORE. That is a way to secure co-op, and we can have very efficient results with that. And I will not go into detail because Ricardo will present it. So the scope of the co-op document can be seen in 3 ways. Either we compress co-op UDP IPv6 and a single rule, or we have a specific rule for co-op, and we have maybe other rules for the rest of the stack. Or for a case of OSCORE, we have 2 rules. One, we will focus on the inner header, and the other one on the outer header. So I will go very quickly in all the fields because I don't have too much time. But let's say that it's a regular mechanism that we have defined in SCHC, so it's not very complex. And we go in for all the fields that we have in co-op and all the options. So what is important, for example, for type or code, this is a symmetric field because you find it in request and answer. But since the value is not the same in request and answer, you can use that to have a better compression. So it's what we say. For message ID, we have a message ID in co-op that is in 16 bits, but it looks too big or very big for Lpwan because we will have less traffic. So there is some way to reduce this side. So it's a use MSB, for example, for message ID. So we explain how to do it, and we can recommend to use a proxy when the client is outside of the LP1 network to shorten, to put the message ID in some short value to be able to do the compression. Same thing for the token. And for the token, we had also something that talk about the length of the token, because the token has a variable length. We have two ways to carry this variable length. It will be to send directly the token value and a length done by check, but it can be a contradiction with the length given by CoAP. So we say you have to use the length given by the token length field of CoAP. And so it's imposed to create a new variable or new function for the length. For accept and content, so we have the regular way to do it. For these fields, is the same thing. You can suppress them, use MacPin list, MSB, or you can ignore them. URI-path and URI-query is a little bit more tricky because we have variable length compression, and also we have the position. So this field can be repeated several times in CoAP. So that's why we need the position, and it exists in the standard way. But there is some case where we can have a better compression. It's, for example, if you have a field that is /A/B/X and /C/D/Y. So the first position can be A or C. The second position can be B or D. So if we use the regular way to do it, we will have one bit that will be used to compress and say if it's A or C, and one other bit that will say if it's B or D. And what we propose is to have a way to put in a matching list several elements like this. And this way we use only one bit to carry it, and we avoid some illegal value like /A/D or /C/B, for example. So it's something we introduce in the draft, and we want to have feedback from implementers to see if it's a good idea to do that. So we have also to explain the length. So in the general document, we say that we have to send a length, but we don't give the unit. It can be bits, it can be byte. And here we specify that the unit is a byte because it's the unit for these options. So this way it closes ticket 27. Okay, so we continue with all the fields, so there is nothing to say here. There is a comment here from Evo on the mailing list, is that we say that we have always to send this value. It's because, in fact, these values are generated dynamically during by the system, either because it's a tag for catching, or it's something that is written by a post, and so we cannot forecast the value, so we have to send it. We cannot compress it. We talk about the other RFCs, so that define options. So we had discussion in the mailing list to say, do we allow blocks, or we say that blocks is not usable because we have fragmentation, and in fact we can use both of these mechanisms. So we allow blocks and fragmentation. Observe is something that is quite easy to manage. No response also, and we had also timescale. I will talk about it after. It's something that allows server to be aware about the time he have to keep a message in their memory. What we have to do next is, for example, to make the text more clear. In fact, we put a lot of most in what we have to do in the rule, and it's not a good choice because, in fact, people can have more liberty to do what they want with the rule and to adapt to their behavior. So we have to rewrite the text to make it more liberal. And we have to add maybe some example. Right now we have a very simple example of CoAP. Maybe we have to look at some traffic coming from different platforms like Komai. And that's for my presentation. So if we have you have questions.
It's good. So just for the, because Oscar comes right after, And for those core presentation, if we can also make it a little bit shorter, that would be really great. So, Ricardo, can you please request the person? Hello?
Hello. I have to request. Are you getting me?
We hear. Can you talk a little bit closer to the mic?
Yes. Do you hear me now? Yes.
Yes, we hear you. So, Ricardo, if you are able to, because you already presented some parts of the slides, and Oscore is a very good application, but we are running a little bit short on time. So, if you're able to make your presentation in 5 minutes to 10 minutes, that would be really perfect.
Okay. Okay. Yes. Yes. I'll try my best. Yes. Okay. I will be speaking about how we go about compressing Oscore with SHIC. So if we can go to the next slide. Okay, so basically Oscore has a main mechanism. What it aims to do is protect as much of the message as it can while leaving the fields of co-op or the co-op message that are necessary for proxy operation out in the open. So what we identify is that inside of how it works, it splits the message into a plain text and is sort of a proto-outer header, which will contain the encrypted message. And so what we say in order to compress this effectively to get everywhere, if we go to the next slide, the idea basically is to compress everything. So compress the plain text, the inner plain text before it is encrypted, and also then compress the outer message, the protected message, to get to the outer fields. So this is the basic mechanism that we will be operating with. So if we can go to the next slide. Okay, so if we look at the inner compression, as we call it, this is when we compress the plain text. This looks basically like a regular co-op message. I mean, it has basically the same syntax. It has the co-op code options and then an optional payload. So we can compress this pretty much the same way we compress a regular co-op message. There's no additional rules or different treatment that we need to do. We can go to the next slide. So the outer compression, this one will have more of the, it will have most of the fields actually. It will have to deal with type, the token, and so what pops up that is different from a regular co-op message is that we now have to handle the Oscar option, which is the new option that defines the behavior of the draft. And so what we propose is going to be to divide this option into 3. So if we can go to the next slide. So basically, the Oscar option is the one that has the information, the cryptography information that we need in order to decrypt and encrypt the message when we do the exchange. And there's 3 basic pieces of information that are contained in the option. And what we propose is that in the parser, we divide this option into its 3 parts. And so this makes it easy because then with we can mask off the most significant bits and only send the information that actually changes the most. And we have an example in the next slide. And here we see mostly what we care about is the PIV, which is a sender sequence number for each message we send. And then there's also the key ID, which identifies the server. These are our most important parameters that can sort of change. And the rest we can usually mask off, we have found out. If we can, and well, okay, so here we can see the results. We tried it with, this is a GET request. And so we compared the result of compressing with SHIC the GET request without protection and with Oscar protection. And we see a cost of 10 bytes for the encryption. And we can see these additional bits are, they are shared mostly from the PIV and the KID, and then there's also a token that is added because of the encryption. And then if we go to the next slide, we have the same thing with a content response. There's a bit of a difference in how requests and responses are handled by Oscore. But we see the same cost of 10 bytes, and this has been fairly consistent with the examples that we tried. So this is about what I had to say. I don't know if there's questions or.
There's a question on the mic, Ricardo.
Göran Salander from Ericsson. Well, I'd like to thank the authors very much for including OSCORE in this document. It's very, very nice. And since OSCORE has this inner and outer part, you could use SHIC on applied twice. And I think that's very well described in the draft. I had the chance to talk with Laurent and Anna yesterday, and I promised to come back with detailed comments. I don't have them at the moment, but we noted the one thing about slight confusion about the term ciphertext. So we are using in OSCORE the same definition as in RFC 5116. So that's the standard reference for authenticated encryption. And ciphertext there includes the authentication tag. So there is a single output. And the authentication tag we obviously can't compress. So that's something that we have to add. But otherwise it looks very nice, and I'll come back with more specific comments. I also want to thank for this very pedagogic presentation of OSCORE. It's actually the best we have. So people who don't know anything about OSCORE, I point to these slides because that's the best introduction. Thank you very much.
Okay, thank you.
Excellent, Ricardo.
Hi, Francesca, one of the OSCORE authors with Göran. I don't know if Ricardo can hear us.
Yes, I can hear.
Okay, good. So I also read the draft very quickly, and in particular the OSCORE part. I don't have the co-op part comments yet. I have a couple of comments and I try to be quick. So a couple of minor comments. I thought in the example it would be actually good to show the inner compression as well, like the actual how the inner compression works, because right now it's only the outer compression that it showed.
Okay.
Then I think I understand from the draft that when you use OSCORE, you have to mandate two set of rules for inner and for outer.
Yes.
And I see nodding, yes. And I think that would be good to have it explicit for people who do not understand that, like just to clarify that.
Okay.
Another thing, in the example, I saw that there is no field for key ID context. Now, in OSCORE, you can not use the key ID context, but I was just wondering, if you define that field, do you always have to have it in the rules and have it like maybe empty byte string, like equal to empty byte string or something like that? So not only for that field, but maybe for all the OSCORE fields. If you use OSCORE, you have to include the OSCORE fields in the rules or something like that. Maybe that needs to be clarified.
Okay.
Another comment was, so you include what we call the flag bits. So this is maybe a bit obscure for people who do not know OSCORE, but okay, time out or?
You have 1 more minute to finish, and thank you very much for this question.
Okay.
But mailing list anyway.
Yeah, of course. Okay, let me just take the most important. Oh, I think this one is a good one. So we use sequence numbers in OSCORE, and we define that we have 5 bytes for sequence numbers. And when you use SHIC compression, that gets reduced a lot depending on how much you compress it. And what happens when in OSCORE, when you finish the sequence numbers, you're supposed to rekey. So what do you do when you use SHIC and you finish your very short number of bits? For sequence numbers, either you add something in the text to say, listen, you have to rekey, like 5 bytes is not the maximum that you can send anymore, or you specify like how to change a SHIC context or something like that. I don't really have a proposal for this, but something to think about.
Okay.
Yeah, I'll send the rest in the mailing list.
Okay.
Okay, so thank you very much, Francesca. Thank you, Göran. Thanks, Ricardo and Laurent. Thanks for this work. And that's actually really what is going to be driving also the SHIC over co-op right now, because there is, we were waiting for some time to have reviews from people that come more from the co-op world. And right now, I think that with this work, it's really, we're getting where we needed to be. So with this, I'm cutting the line because we need to move with the next presentation. So thank you very much, Ricardo. And the next presentation is going to be Nicolas Sarnin for the SHIC over LoRaWAN. So Nicolas, the floor is yours.
Thank you. Can we get to the next slide?
Just let us know when we switch slides.
It's a little bit.
So I'll try to be quick.
Yes.
I know we're late.
You have 10 minutes for your slide. So from now on, you have 10 minutes for the presentation. So you have your 10 minutes.
This is the first presentation of the SHIC over LoRaWAN draft. I'll first very briefly introduce LoRaWAN for those that don't know it. In LoRaWAN, which is a Lpwan technology, we have 3 classes of devices. So they are represented from the lowest power to highest power class here. Class A is really the lowest power class. The device transmits whenever it wants, and then opens 2 tiny receive windows following every uplink. So the only time the server or the network has an opportunity to talk to a device is following an uplink. Class B devices behave exactly like Class A device. They can talk whenever they want. They open this RX1 and RX2 slot. But on top of that, they also open synchronous listen window or reception windows with a programmable periodicity. So in that case, the network can initiate a downlink to a device in any of those scheduled listen windows. You have a latency, which is the periodicity of those listen windows, but you can initiate a downlink from the network. And in Class C, the device is basically listening all the time when it's not transmitting. So clearly, Class C is not for continuously battery-powered device, but it can be used temporarily, and it has the lowest latency because basically the network can talk to the device whenever it wants. So those 3 classes of device come with different will have different impact on the way we perform, for example, fragmentation on SHIC. So we're going to have to describe the SHIC fragmentation with some parameters that are different for those 3 classes of devices. This is just what I wanted to introduce. Thank you. The document status. For the moment, we have mapped the LoRaWAN architecture to the component of the SHIC framework. We have also described, we have given the technology-specific parameters for fragmentation on LoRaWAN, or at least we have proposed the first set of parameters for the 3 classes of devices. And I will be seeking for this, we have made some trade-off, and I will be seeking feedback from the audience on some of the trade-offs we've made at a later stage in this presentation. Okay, good. So here is typically the selection of parameters we've done today for fragmentation. The fragmentation works differently on the uplink, so from device to SHIC gateway, and in downlink from SHIC gateway to device. And that's actually linked to the asymmetry of the network. We have far more uplink capacity than we have downlink. We can tolerate a lot more uplink messages than downlink messages. So keeping the number of downlink messages to a minimum is really paramount for us. So on the uplink, we're using a window of 8 fragments. So this is why FCN is actually encoded on 3 bits. Rule ID is on 3 bits. We have 1-bit DTAG. This DTAG field is simply actually used to be able to be sure we're actually cleanly separating 2 consecutive fragmentation sessions. So it's really alternative between 0, 1, 0, 1. Same thing for window. Window is 1 bit, and this is used to clearly separate 2 consecutive window. The payload might be any number of bytes, as of course it has to fit into the limitation of the L2 layer. So this was designed to get an exactly 1 byte header, because LoRaWAN is byte oriented, so L2 word is 1 byte. So this uplink fragment, the selection of the rule ID field as 3 bits was actually really designed to end up with an 8-bit header. On the downlink side, we can basically acknowledge every single message. So fcount is now only 1 bit. So all messages have a 0-bit fcount except the last one, which is an all 1 fragment, which is actually therefore has a 1 in the FCN field. every single downlink from the network is actually acknowledged by the device and retransmitted if it's not acknowledged. Peculiarity here, because our header is now 6 bits, the payload of each fragment is actually X bytes plus 2 bits each time. And we apply the appropriate padding in the last message or in the last fragment of the fragmentation session. So there are a few questions I have for the audience. So currently we're encoding rule ID on 3 bits. We have one rule ID which is actually reserved for fragmentation. So that leaves 7 rule ID for UDP or CoAP header compression. We think that is enough because we have worked out typical CoAP example, and they only required basically 3 rules. So what we have implemented are an unconfirmed post, a confirmed post, and a confirmed get method, both uplink and downlink, and we can do that with 3 rules. But basically, we still have very naive in this field. We are newcomers. So basically, I would like to understand if, from the experience of the people, what is the minimum number of rules that people are actually working with. This is the main question I have for you today. Next slide.
Do we want? Is there anybody?
Okay, so we can do that now. Thank you.
No, there's no
feedback on that. Okay.
Nobody comes.
No problem.
Sorry, Nicolas.
So.
Okay, so maybe I'm not going to walk my chair head off. Just to share a couple of thoughts on that point. I think that it would be good to have a couple of default rules that will be used, by any device. I mean that can be applied to all devices, and they're having a limited set of rules would be good, and then probably use some of these rules as some kind of a prefix for extended rules that can be used in future deployments, where you can say, well, if it starts, I don't know, with 111 or 110 or something like this, then actually the rule ID is longer, and go into a much wider, a much bigger set of rules that will be specific to the device.
Is that actually allowed by the current SHIC spec to have a variable length rule ID coding?
Yes, that's one of the points.
Okay, so
yes.
I had totally overlooked that. Thank you for mentioning it. I will have to rethink about that then, because that may be a good option.
Mm-hmm. No, but it's very consistent with what you proposed, right? So the things that you're saying is okay. Well, there's this default bootstrapping set that is of 3 bits, and parts of it it's going to be like, okay, well, like one of them is going to be pointer to the extended set that could be
exactly
something very rich.
So another question there is basically to simplify the implementer's life and make implementation more consistent across different platforms. I think it is good to actually specify common rules. So do you think that in a technology-specific document, it would be a good idea to say, for example, rule 0 is reserved for fragmentation? Because actually in LoRaWAN, we know we have to implement fragmentation in some cases, or should we actually leave the maximum possible flexibility? What is the spirit in this IETF group?
So that's definitely a discussion that we would like to have on the mailing list. I would feel that it would be good to have some initial set of bootstrap methods that is, that could be common for all the devices, so that things can start up. It can be something pretty basic, as you said, maybe 0 is going to be for fragmentation, and then people can start working without needing any complexity, and then can improve.
My feeling exactly to ease initial interop is the more you specify thing at the beginning, the easier it is to get started.
I agree totally on what you said. Just one point is that rule 0 doesn't exist. You have to say rule 0 on length, like an IP prefix.
Sorry, could you state that again?
Because you have to put a rule on a length because it's variable. So if you say 0, is it 0 in 2 bytes?
I understand.
Bytes?
So I was meaning 0 in my 3-bit context, but I will specify this. Okay. Thank you.
Yes, think also about the guys who will write some Wireshark thing or equivalent to format what you send in the air. So they will love it if you have common
Okay,
values.
yes, because you can do standard filter. Okay, so basically, then in that case, in the technology-specific document for LoRaWAN, I will try to propose a very basic set of rules that any device will need anyway.
Okay,
sorry.
so thanks. If you have like a minute or so to wrap up, and I think that you have a question.
So I'm nearly finished, thank you. So still to be done, we have to describe LoRaWAN security model. So LoRaWAN at the L2 layer has a strong security implementation, but we have to describe what security is actually provided by LoRaWAN and to this SHIC layer. Describe specificities of 3 device classes. So typically in terms of downlink latency, you cannot ping a LoRaWAN device if it's not a class B or class C device, for example. And I would like also to provide a detailed numerical frame exchange examples, in particular fragmentation, to make sure implementers get things right. So maybe that will be redundant with the main SHIC documents. I have to understand this. If it's not redundant, I will provide technology-specific examples. And last, I would like to just our feedback on SHIC. We have started implementing things, so we really like the overall simplicity of the scheme and the fragmentation scheme. We find it very elegant and effective. We would like to propose 2 features for actually future development, or actually it's food for thought. And what I call implicit introduction and conclusion rules. So rules that would always be applied at when a new packet is received or at the end of a new packet, that because those rules would allow actually using a SHIC even on non-SHIC very simple legacy devices. So basically introducing a header in front of a payload and concluding it by some trailing stuff, for example. And also, of course, it will be provisioning of device and gateway is going to be a nightmare. So we will need to find a way for a device to actually be able to convey its SHIC rule to the gateway and not have to do that totally out of bound. So this is, I'm pretty sure that's a topic that already exists somewhere, but I'd like to contribute to that if that's possible.
So Nicolas, we plan to recharter as soon as SHIC is out for provisioning the state that's needed for compressions, and right now the work has not really started, so it's really open to multiple ways of doing it. So yes, we want to do this work, we want to recharter for it, we hope that we'll get support from the
Okay, thank you very much.
Any reaction on the author for the first question, the introduction and conclusion rules, because we discussed that on the mailing list.
Okay, that's a great point, but let's discuss it. I mean, I'm a little short of time, really sorry, but it's really a great question, and thank you very much for the feedback. And I think you have the last question.
Yeah, I'm not familiar with the process, but basically we would like this document to become an official draft and to be able to progress it inside the work group. So I have no idea what is actually the real process there, as I'm a first timer.
Well, Nicolas will call for adoption. And if it's chartered, we can call for adoption. We can do that now and confirm on the mailing list. And then we'll ask you to do some operation on the document because it officially becomes ours and not yours anymore. As long as there is your name on it, you can write whatever you like, right? As soon as it's a workgroup document, then we need to talk on the mailing list before we make a change. So it becomes more heavy, but now it's a workgroup document. A workgroup document doesn't necessarily mean that you're going to get an RFC, because sometimes we abandon a document, but I expect this one would go to RFC. Okay, any opposition for calling to adoption? Okay, so we'll confirm that.
Thank you very much, Mr. Chairman.
Okay, thank you very much, Nicolas. And it is up to Juan Carlos now. So Juan Carlos, you have around 10 minutes.
Yes. Okay. Thanks. So Juan Carlos Zúñiga, I'm going to talk about the SHIC over Sigfox draft, but I'm also going to focus on the discussion on ACK on error mode and actually NOAC as well. Next slide, please. So I'm going to be brief on the updates to the draft. Now we have revision 3. Again, talking about the network architecture equivalences. We added for this version some rules, parameters, and usage, specifically talking about values and timers. And like the previous presentation, we are focusing on byte-oriented, so we are suggesting having an 8-bit header or SHIC header that we think it's very useful for implementation. However, we saw that there were some clarifications needed on the draft, specifically for the NOAC and the ACK on error mode, and therefore the discussion that we had in the next slides that I'm going to present. So starting from the NOAC mode, Dominic touched briefly on this, but the point here is that right now the draft assumes, it's not mandated, but it assumes pretty strongly that FCN is equal 1, meaning that, well, n is equal 1. FCN is 1 bit for the NOAC mode. So basically we can only send 0, 0, and then send the all 1 at the very end, without conveying any information about the number of fragments that are going to be sent when there's no acknowledgement. What we are proposing is to clarify or relax the specification so that n higher than 1 can clearly be allowed. In this case, for us, we see value because we would like to convey information as we were discussing before. Semantically, if we didn't start at the maximum value, we could hint the number of fragments that are going to be sent as part of this transmission up until the end. Again, assuming that we have an FCN that allows a number up to 8. We don't start at 8, we start at 5, let's say, and therefore it's clear that we are going to send 5 fragments, even if we're not asking for acknowledgement at the end. The next one is the ACK on error, and this is a little bit more complicated. So I'm going to summarize it here, and then we move to the next slide with a figure. But basically, when we were doing the studies and simulations, we realized that losing a single all 0 fragment, meaning the last fragment of any window, or a SHIC ACK, would create a complete loss of session. And this is basically due to the fact that the draft mandates aborting the session whenever the W bit is out of sync. And at this moment, losing any of those packets would necessarily create an out of sync, and therefore we would have to abandon the whole session. What we saw, though, is that if we allow in the ACK on error mode to keep track of the last 2 windows, the receiver can request retransmission of any lost packets and therefore come back to sync and recover the session. From what we saw, the probability of well, there's a little risk here, of course, because we are playing with the W bit, and if we move over several windows, there's a probability of overlapping onto 2 windows passed. But this probability of overlapping 2 windows passed, as well as having the complementary fragments, is quite low compared to losing either a lost all 0 or a SHIC ACK. So in neither of the directions. So if we move to the next slide, I'm going to just explain this in figures. So basically what we see here is that we have a sender sending, let's say, 4 fragments, and the receiver either losing the last fragment, meaning the all 0, or the sender receiving the ACK from the receiver would create a complete loss of session. Why? Because in ACK on error, we are not expecting the ACK if the transmissions went through correctly. So basically the sender would interpret the lack of response as if everything went fine, and it would keep sending at this point W1 or window 1, and then the receiver would see a window that is not expected, then it would necessarily abort. This is a very bad situation, again, because it could be created either from losing a message from left to right or a message from right to left. If we move to the next slide, please. What we are proposing here is that we allow to keeping track of the last two windows, meaning we go through the same situation. We can get there either from losing the all 0 or the ACK, the first ACK for window 0. We then, if we put ourselves in the sender position, we believe everything went fine, so we transmit the whole W1 window. At the end of the window, we wait to see if there's any ACK, and there's an ACK, but in fact the ACK goes for the previous window, not the current window. In this previous window, we can say which were the missing fragments. In this example, let's say it's all 0, just for easy explanation. We retransmit the fragment all zero, and we would expect a chic ACK for, again, Windows 0 saying, okay, now we're fine with Windows 0. At this point, what we can use is the MTO0 message that Laurent had proposed, which forces a chic ACK response. But we would do it for the current window, so then the next window. We are fine with Windows 0. We force now a second ACK, but for Windows 1. And this ACK, again, could inform if there were any missing packets. In this example, just for simplification, we say there were no missing packets. So we get back to sync, and we move we resume the normal operation.
I have two small reactions here. Depending on the technology, the ACK Windows 0 could be sent earlier. That's one. Because
Okay.
if you, for instance, we talk about LoRa, then on the first W1, you can say, missing ACK W0. The other one is I'm just thinking about Laurent's final state machine and wondering if the discussion we had during all this meeting about now making it normative is quite compatible with adding this to it, because it seems like now you will have 3 dimensions on the final state machine. So that really raises the point why it's not necessarily a good thing to want to standardize the FSM, because if things come like that, make it so complex that you can't even draw it anymore.
And if I may say, just the text that I sent on the list last night considers what would be needed to change for this on the text. I haven't got to the state machine, but at least the text reflects what is needed for this.
Okay, so after Anna's comment, so first I think that you need to have at least an error in the uplink and then lose the downlink. So it's not an or here; it needs to be an and in the graphic.
No, because if you don't receive that, you cannot send that.
It's a con error.
But if you lose only, so it's only, you need to have both of them.
No.
Okay, but I mean the or here is not clear, and
it's an or, believe me.
And okay, so very short because we need to.
So
move on to
very
the next
quickly, for me, what you are doing is that you are choosing a con error because you don't want to use your downlink. But if you have an error, you want to use ACK always because you need to ACK and you don't want to abort ACK on error, and you don't want to go to ACK always. That's what you want.
Okay.
Okay, so we need to. I think if we can bring this on the mailing list and talk it over to see where we are using exactly what.
Okay, so maybe a proposal to move forward. I did send the 3 points last night. Yeah. Maybe we can separate it in tickets or in discussions in 3 different threads. One is the one that I discussed before, the ACK, the no ACK. This is the second point.
Yeah.
And the third one is in
the first. You say that you have simulation results from this.
Mm-hmm.
So is it possible to send this result to the list to see what is the global improvement of this method compared to?
We can look. Yes, I think we may want nothing asking, but.
Yeah, so we need to move on, please. So we continue with the discussion, and yes, one of the things is these are changes that seem changes. So we need to see if we do want to make these changes. So what is the reason to make them? Right? It is certainly an improvement, but there is a cost for the sender. There is a cost for describing this. So we need to see, do we really want to do it?
Just very quickly, Carlos Gomez.
Okay. I'm going to talk. I'm Edgar Ramos, and I'm going to talk about narrowband IoT, CHIC over narrowband IoT, and the draft we are writing about. And today is mainly a little bit describing why it's a little bit similar than last session, why it's a bit special, and also what are the possibilities for continuing with the draft. So if there is any comments from the group about this, I would be happy to get them. This is a little bit to remind you that in Narrowband IoT, basically we have two ways of transmitting data. One is using what you could say the control plane. So we have actually basically a stack that includes control plane protocols, which are RRC and NAS. And then we have the kind of the normal operation mode that also that all the mobile phones use, which is the user plane, where you can see basically the application IP and then the access stratum, which is PDCP, RLC, MAC, and the physical layer. So basically, we have to live with this in Narrowband IoT, and this in the top is the architecture from the network. And the reason why I bring this is so that if analyzing how we can use SHIC, then I came out with this conclusion. So basically, we could either use it in 3GPP standardized interface, or we can have some kind of over-the-top use of SHIC, which it would be basically like the same thing that if would not be IP traffic. So it's non-IP traffic for the 3GPP network perspective. So from the 3GPP standardized interface, I think it's good that we have to consider this, and it's because ROG was also standardized here in IETF, and it was adopted by 3GPP. And then if you, after my analysis, I thought that basically you can replace it. You can take ROG in all the places where it says ROG, and you can have an alternative, which could be SHIC. There is not really very much to be done in the standard other than that. And it's more about, well, then there is something about the provisioning of parameters and so on, but that's another thing. But basically, from the functional perspective, it's pretty much the same thing. So that's not a problem, but I think that's one way to go. But it's not to us, of course. At the end of the day, it's up to 3GPP if they want to adopt it. What I have heard from feedback from people that are working in 3GPP and standardization of Narrowband IoT and 5G MTC, so machine type communication, is that they are really interested in this, and they would like to see if it's a good standard, how to introduce it. So there is an interest for it. What would happen is that basically there would be two places where there would be SHIC entities, if that's the case. So one place would be the NAS, basically, you could say MME, but now for Narrowband IoT is the CSGN, which is a node that has many things. And then in the NAS level, then you would have for this kind of control plane operation. Then there you could have the SHIC compressor and the compressor. And then in the other case, when you have the actual connected mode, so basically the difference between these two is that in one you have security. The security has been established in the access stratum. Sorry, in one it haven't been established. In the other one has been established. And then the compression changed to be done in PDCP instead of be done in NAS. So then this has to be considered as well. So how we do this change? So does it work straight away? So if you have context from NAS, then can you reuse them in PDCP, or is it a totally different set of rules and so on? So these have to be thought through. Then we have the other option, which is that we have, it's misspelled there, but well, SHIC. Yeah. It's SHIC over the top, basically. So the application layer, and it means that you don't require 3GPP standardization. Anyone can use it. And even if we have 3GPP standardization, still you could use it. So it doesn't preclude that you can have both. But then the only trick of this is that, well, it will be treated as non-IP traffic by 3GPP. And then there are two ways of handling non-IP traffic. I will show a little bit about that in the next slide. But then the main consequence is that intermediate hops cannot directly understand those compressed headers. So it means that if you want to do something on IP layers before the packet reach the terminal, then that is not possible unless there is some mechanism to get access to the context.
Quick question: can we? So if we have to go all through this non-IP path, do we have a guarantee that the packets are in order?
They should be if the packets arrive in order to the core network. So from the core network upwards or downwards, I don't know how to say downwards, maybe to the UE, they should be in order. But then I don't know if in the middle something can happen. It depends. For example, here we have IP tunneling as one option. Is UDP most probably? And
if you're doing multipath loss balancing on all those core networks, you might have your packets out of order. So I'm asking, so which means that if we tunnel, we need to sequence the tunnel or something like that.
Could be, yeah. So that's a good point. Something to check actually. But well, these are the two options basically. So one option is that goes over tunnel, and then how the tunnel is done and is implemented, and what protocols are used. That is pretty much up to the operator. It could be even TCP being used to transport. Then you have the other option, which is the SCEF services, which are also quite, let's say, proprietary. So it might be an operator that has his own SCEF services and APIs, or it might be something like OMA or one M2M that has pseudo standardized or harmonized. And that is...
You're out of time, Count.
Yeah, that's my last slide. So that is basically the options. And well, then basically this is the type of feedback I was expecting. So we expect now to work with this, and then I think we are going to improve the document. Unfortunately, we missed the deadline for the document for this session, but we have actually in GitHub a newer version. Yeah.
Okay, thank you, Charlie. A couple of minutes, so you'll have 3 minutes to finish your slides, but I would like to thank you very much. Thank you very much, Edgar. I am really very, very happy with the progress I see on the NB-IoT side. And it's really also this positive feedback that you give us. It's also very, very promising to see that the technology is actually going to get used. So thank you all for that. Thanks, Alan. And Charlie, we're going to have the pleasure for closing the session.
Can you hear me? I'm Charlie Perkins, and this is a very short presentation. We made a draft and put it out earlier this week. So I don't expect anybody had much chance to look at it. And besides that, it's a quite simple draft. It's not really complete, but at least it's a start. And if you take a look at it, your comments will be appreciated. So I'm here basically to tell you about what's going on in 802.15.4W, which is the 802.15 task group that's dealing with low power wide area things. They are chartered to basically extend some of the file layer parameters to deal with a wider set of use cases, which have been extensively discussed during the interest group and study group formation. So now we have the task group that has the charter basically to produce revisions to 802.15.4 for the purposes of low power wide area. Now this SHIC for 802.15.4W is not an official IEEE contribution, but it's done by people in 802.15.4W. And so I'm not exactly sure how the authorship would be represented, but it won't be an official thing. However, I think the IEEE 802 and IETF coordination committee will know about it. So the point is that to show how we can use SHIC for this, and there is a standing committee for IETF and 802.15, and it seems to me that that's a good place for this work to actually happen. But no matter what, 4W will be involved with it. Okay, so the document is relatively short, just goes through. There was a nice, see this mailing list thing from Anna, said about how you go about specifying the parameters in such a document as this. So we basically followed those recommendations. We think that the size of the ruled ID should be 3. With 802.15, you need probably 8-bit boundaries, so you can choose 16 bits or 32-bit CRC, but I think 32-bit would be preferred. And pretty much high on my list of things to care about was fragmentation, and 802.15 already does fragmentation, so you could beneficially use SCHC context management for compression along with 802.15.4 fragmentation. And if you did that, then that simplifies your parameter selection quite a bit. On the other hand, it needs to be considered whether this the SCHC fragmentation is better than 802.15.4 because it's specialized to a single hop. And that has not been done yet. And I will definitely urge people in the 4W to analyze that. Aside from that, just since I am up here, I will tell you that we've made good progress in 4W. That, as I mentioned, that was chartered to produce some new file layer parameters, and this is not my strength. I know sort of what a convolutional code is, but I don't know how to design them. And but we had 6 proposals, and I have to say that they are really quite creative. So I think that it's going to be a good while before we go through all of this. And probably next year we'll have either a combined candidate or something that has support of the working group to go forward because, well, this timely work. So I think that's my last slide. I'm Charlie P. at computer.org. If you have any questions or whatever, please don't hesitate to ask. And we would love to bring any concerns from this group back to the 802.15.4W working group.
Thank you very much, Charlie. We are only 2 minutes past the hour, which is really exceptional work from everyone. Thank you very much. And thank you for submitting the draft. We're really happy to have also the 802.15.4 draft. So right now we are on good track with all this. So that's the end of the group. Have a good afternoon or evening or night, wherever you are. Thank you.
Everybody sign the blue sheets. Dominique?